Right now, as you're watching this, something absolutely extraordinary is unfolding 3 billion miles away from where you sit. In the cold, eternal darkness beyond Neptune, where sunlight barely whispers across frozen landscapes, there's a world smaller than our own moon that's about to completely shatter everything we thought we knew about how planets truly behave. This distant sphere, so incredibly small you could fit it comfortably inside the United States with plenty of room to spare, has been quietly rewriting the fundamental rules of planetary science. While we've been going about our daily lives here on Earth, the most advanced telescopes humanity has ever built have been peering into that remote corner of our solar system, uncovering stunning secrets that are forcing the world's top scientists to question basic assumptions they've held for decades. You see, when something is that far away and that small, it should be simple, dead, predictable, a frozen rock drifting silently through the cosmic void, following the laws of physics we learned in textbooks. But what we're discovering challenges those very laws in ways nobody could have possibly anticipated. The implications stretch far beyond this one mysterious world. What we're seeing suggests that our entire understanding of how planets form, evolve, and behave might be fundamentally flawed. And if we're wrong about this, what else have we gotten wrong about the cosmos around us? What you're about to learn will forever change how you see our solar system and make you question what other secrets are hiding in the darkness, waiting to surprise us all. Here's what's happening right now that has scientists completely baffled. The James Webb Space Telescope is detecting atmospheric activity on this distant world that simply cannot exist according to our current understanding of planetary science. The chemical processes Webb is observing should be absolutely impossible at those temperatures and distances from the Sun, but that's just the beginning. The surface features we're discovering shouldn't be there either. Geological formations that require active processes that demand energy sources this world theoretically doesn't have. Features that suggest this tiny frozen sphere has been far more alive than any textbook ever predicted. And here's the revelation that will reshape everything we thought we knew about life in extreme environments. By 2030, these discoveries are going to fundamentally change how we search for life on the thousands of exoplanets we're finding beyond our solar system. What we're learning about survival in the most impossible conditions is about to revolutionize astrobiology itself. But to understand why these discoveries matter so profoundly, we need to go back to the very beginning, back to when humanity first glimpsed this mysterious world and had no idea what secrets it was hiding in plain sight. Think back to when you first heard about Pluto. Maybe it was that tiny distant dot in a textbook, just a cold, dead rock at the edge of our solar system, right? If you're fascinated by hidden stories behind space discoveries that mainstream news barely touches, hit that subscribe button. This channel digs deep into cosmic mysteries that deserve more than quick clips. We're all in this together, trying to make sense of a universe that keeps surprising us in ways, and whatever mental image you have of Pluto right now is about to be completely transformed. The story begins back in 1930, when a young astronomer named Clyde Tombaugh was methodically comparing photographic plates at Lowell Observatory in Arizona. After months of painstaking work, he spotted something that would change our understanding of the solar system forever, a tiny point of light moving against the background stars. They called it Pluto. For 76 years, Pluto held the title of our ninth planet. But in 2006, as astronomers discovered more objects like it in the outer reaches of our solar system, they made a controversial decision. Pluto was reclassified as a dwarf planet, smaller than expected, but still mysterious and distant. Just how distant? 3 billion miles from Earth. To put that in perspective, if Earth were the size of a marble, Pluto would be sitting about 25 miles away. At that incredible distance, the Sun appears as nothing more than a bright star, providing virtually no heat. Surface temperatures plummet to minus 375 degrees Fahrenheit, cold enough to freeze nitrogen solid. And Pluto takes 248 Earth years to complete just one orbit around the Sun. For decades, these numbers painted a simple picture. Pluto was essentially a frozen time capsule from the formation of our solar system, locked in permanent winter, geologically dead for billions of years. Then came July 2015, and everything changed. NASA's New Horizons spacecraft, after a 9-year journey across the solar system, flew past Pluto and beamed back images that stunned the scientific community. This wasn't the cratered, lifeless ice ball everyone expected. Instead, they saw a world with vast nitrogen plains, towering mountains made of water ice, and complex terrain that suggested recent geological activity. Recent, meaning within the last few million years, the blink of an eye in cosmic terms. But even New Horizons, remarkable as it was, could only give us a snapshot. A quick flyby that raised more questions than it answered. That's where the James Webb Space Telescope comes in. Launched in December 2021, Webb represents humanity's most powerful eye on the cosmos. Unlike traditional telescopes that capture visible light, Webb specializes in infrared radiation, heat signatures that reveal the chemical composition of objects across unimaginable distances. Its unprecedented sensitivity can detect atmospheric gases, surface materials, and thermal patterns with a precision that seemed like science fiction just decades ago. When Webb turned its revolutionary instruments toward Pluto, scientists expected to fill in some details, maybe confirm what New Horizons had suggested. They weren't prepared for what they found. What the textbooks told us was beautifully simple. Pluto, they said, has a thin nitrogen atmosphere, essentially just a wispy envelope of gas slowly escaping into space, minimal activity, basic chemistry, the kind of straightforward atmospheric behavior you'd expect from a frozen world receiving 1,000th the sunlight that Earth gets. What James Webb detected was anything but simple. Webb's infrared spectrometers began picking up atmospheric signatures that made no sense according to everything we thought we knew about dwarf planet atmospheres. The nitrogen wasn't just sitting there quietly escaping, it was actively interacting with methane and carbon monoxide in ways that require energy sources and chemical processes that shouldn't exist at Pluto's distance and temperature. Dr. Sarah Hurst, a planetary scientist at Johns Hopkins University, put it bluntly when the data first came in. We're seeing atmospheric chemistry that defies our models. These interactions should be impossible in Pluto's environment. Webb detected methane clouds forming and dissipating in Pluto's upper atmosphere, actual weather patterns occurring 3 billion miles from the Sun. But here's what's truly mind-bending. These processes require precise temperature and pressure conditions that our atmospheric models said couldn't exist there. The scale of what we're seeing is remarkable. Pluto's atmosphere extends roughly 1,000 miles above its surface. That's like stacking 4 Mount Everests on top of each other. Yet at its thickest point, this entire atmospheric envelope is thinner than a single sheet of tissue paper compared to Earth's atmosphere. Somehow, within that impossibly thin layer, complex chemistry is happening that challenges fundamental assumptions about how atmospheres behave in the outer solar system. Webb's infrared vision revealed something even more startling: seasonal atmospheric changes that occur over Pluto's 248-year orbit. As Pluto moves closer to and farther from the Sun, a journey that takes longer than the entire recorded history of the United States, its atmosphere doesn't just freeze and thaw, it transforms. Chemical compositions shift. New compounds form and break apart in cycles that suggest active, ongoing atmospheric processes. This isn't the behavior of a dead world. This is the signature of a dynamic, evolving system that's been operating for billions of years in conditions we thought would make such activity impossible. NASA's atmospheric modeling teams are now working around the clock to understand how these processes can sustain themselves. The energy requirements alone should exceed anything Pluto can provide through solar heating or internal radioactive decay, yet there it is, happening right now, captured in Webb's unprecedented infrared data. But as extraordinary as these atmospheric discoveries were, they were just the beginning of the surprises Pluto had in store for us. Stop for a moment and really think about what this means for you, for all of us. Every time we've looked out into the darkness and seen a small, distant world, we've made the same assumption. If it's far from a star, if it's cold and tiny, it must be dead. Lifeless, just another frozen rock drifting through the cosmic void. But if we're wrong about Pluto, if this little world smaller than our moon can sustain complex atmospheric chemistry and dynamic processes 3 billion miles from the Sun, then what else are we wrong about? There are billions of objects like Pluto scattered throughout our galaxy. Dwarf planets, moons, asteroids that we've written off as geologically dead simply because they don't fit our narrow definition of what an active world should look like. What if they're not dead at all? What if the universe is far more alive, far more dynamic than we ever dared to imagine? This changes everything about how we think about habitability. For decades, we've focused our search for life on planets in the Goldilocks zone. Not too hot, not too cold, just right for liquid water. But Pluto is showing us that the universe doesn't play by our rules. Complex chemistry, active processes, and dynamic environments can exist in places we never thought possible. You're witnessing something extraordinary, planetary science being rewritten in real time. The textbooks your children and grandchildren learn from will be fundamentally different because of what we're discovering right now. We're not just learning new facts about one distant world, we're learning that our entire framework for understanding planetary behavior might need to be rebuilt from the ground up. It's humbling and exhilarating at the same time. Here we are thinking we understood the basic rules of how worlds work, and the universe keeps surprising us. It makes you wonder what other secrets are hiding in plain sight, doesn't it? And the most shocking discovery, the one that's making scientists question everything they thought they knew about planetary formation, we haven't even told you about yet. Here's what the headlines aren't telling you about those surface features that shouldn't exist. Webb's infrared instruments have detected something that should be impossible: significant temperature variations across Pluto's surface that can't be explained by solar heating alone. We're talking about differences of up to 20 degrees Fahrenheit between regions that receive essentially the same minuscule amount of sunlight. That might not sound like much, but at temperatures hovering around minus 375 degrees, it's enormous. Think about that for a moment. You're looking at temperature readings from a world so far away that the light reaching your eyes left Pluto before you started watching this video. Yet we can measure thermal differences across its surface with precision that would have seemed like magic just 20 years ago. But here's where it gets truly mind-bending. Those temperature variations aren't random. They're concentrated in specific regions that correspond exactly with the geological features New Horizons photographed. The vast nitrogen plains of Sputnik Planitia, the towering mountains along Tombaugh Regio, areas that show clear signs of recent geological activity. Webb's spectral analysis is detecting thermal signatures that suggest subsurface heat sources. Not the kind of gentle warming you'd expect from radioactive decay in Pluto's rocky core, but active thermal processes that require energy equivalent to about 50 billion watts continuously. To put that in perspective, that's enough energy to power every household in New York City. Where is that energy coming from on a world that's supposed to have been geologically dead for billions of years? The contrast is staggering. For decades, we've compared Pluto to Earth's moon, small, cratered, frozen in time since the early days of the solar system. But our moon is geologically dead. It has been for over 3 billion years. The last volcanic activity ended before complex life even existed on Earth. Pluto, meanwhile, shows thermal patterns consistent with ongoing geological processes happening right now. While you've been living your life, raising families, building careers, this distant world has been quietly reshaping itself in ways that challenge everything we thought we understood about planetary evolution. Here's what really gets to you when you sit with this data. We're detecting evidence of geological activity on a world smaller than Australia, colder than Antarctica in winter, receiving less energy from the sun than a single street lamp provides to your front yard. Yet somehow, it's more geologically active than worlds we previously thought were far more likely to be dynamic. Webb has identified specific mineral signatures in Pluto's surface materials that form only under conditions of heat and pressure. Crystalline structures that require temperatures hundreds of degrees warmer than Pluto's surface should be able to sustain. These aren't ancient formations from when Pluto might have been warmer. Spectral analysis suggests they're geologically recent. The implications cascade outward like ripples in a cosmic pond. If Pluto can sustain geological activity under these conditions, then thousands of similar worlds throughout our galaxy might be far more dynamic than we ever imagined. Objects we've dismissed as frozen relics might be active, evolving, and possibly even capable of supporting the complex chemistry that leads to life. But even that stunning revelation pales in comparison to what we're about to discover about the most profound implication of all. Right now, as these discoveries are reshaping our understanding of Pluto, astronomers estimate there are over 2,000 similar dwarf planets scattered throughout our outer solar system alone. 2,000 worlds we've largely dismissed as cosmic debris, frozen remnants from the formation of our solar system 4.6 billion years ago. But if Pluto, one of the most distant and seemingly lifeless of these objects, can sustain complex atmospheric chemistry and active geological processes, what does that mean for all the others? Consider Eris, slightly larger than Pluto and even more distant, or Makemake, with its mysteriously bright surface, or Haumea, spinning so fast it's shaped like a football. We've cataloged them, measured them, and essentially written them off as scientifically interesting but ultimately dead worlds. What if we've been catastrophically wrong? The numbers become staggering when you expand beyond our solar system. Conservative estimates suggest there are over 100 billion dwarf planets in our galaxy alone. That's roughly 15 dwarf planets for every person who has ever lived on Earth. And here's the profound part. If even a tiny fraction of them exhibit the kind of unexpected activity we're seeing on Pluto, we're looking at billions of dynamic worlds where complex chemistry could be happening right now. Webb's ongoing observations are revealing that Pluto isn't unique. Preliminary data from other Kuiper Belt objects shows similar thermal anomalies, similar atmospheric complexities that shouldn't exist according to our models. Each new observation expands the possibility that what we're seeing isn't an exception, it's the rule. This fundamentally changes astrobiology. For decades, scientists have focused on finding Earth-like planets in Earth-like conditions. But life, as we're learning, might not need Earth-like anything. If complex chemistry can persist in the frozen darkness 3 billion miles from the sun, then the number of potentially habitable environments in our galaxy just increased by orders of magnitude. Think about the emotional weight of that. You're living at the exact moment in human history when we're discovering that the universe might be teeming with active, dynamic worlds in places we never thought to look. Worlds where the building blocks of life could be forming and evolving in environments so extreme we previously thought they were impossible. And the timing couldn't be more perfect. Right now, as Webb continues to revolutionize our understanding of our own solar system, other telescopes are discovering thousands of exoplanets around distant stars. Many of these exoplanets are small, cold, and distant from their host stars, exactly the kind of worlds we would have dismissed as lifeless just a few years ago. But Pluto is teaching us that distance doesn't mean death, that small doesn't mean simple, and that cold doesn't mean inactive. By 2030, when the next generation of even more powerful telescopes comes online, we'll be able to analyze the atmospheres of these distant exoplanets with the same precision Webb is bringing to Pluto. And now we know to look for the unexpected, to search for signs of activity in places where conventional wisdom says nothing should be happening. The implications are so profound, they're almost overwhelming. But perhaps what's most remarkable about these discoveries is what they tell us about our place in this vast, surprising universe. Here's the revelation that's going to transform how we search for life beyond Earth. By 2030, space agencies around the world are planning to use Pluto's lessons to completely redesign their approach to exoplanet research. Instead of focusing exclusively on planets in the narrow, habitable zone around stars, astronomers are now developing new instruments specifically designed to detect the kind of unexpected atmospheric chemistry and thermal activity we're seeing on Pluto. They're expanding the definition of potentially habitable worlds to include cold, distant objects that previous generations of scientists would never have considered. Let's be honest about what we're dealing with here. These discoveries don't mean Pluto harbors life. We have no evidence of that yet. What they mean is that the universe is far more capable of sustaining complex, dynamic processes than we ever imagined. And complexity, as we've learned from Earth's history, is often the first step toward biology. But here's what should fill you with genuine excitement. You're living through the golden age of planetary discovery. Every month brings new revelations that expand our understanding of what's possible. The James Webb Space Telescope is just the beginning. More advanced instruments are already being designed, each one capable of revealing secrets we can't even imagine yet. Think about human ingenuity for a moment. Less than a century ago, we didn't even know Pluto existed. Today, we can analyze its atmospheric chemistry from 3 billion miles away with such precision that we're discovering processes that challenge fundamental physics. That's not just scientific progress, that's testament to what humans can accomplish when curiosity drives us forward. Yes, we still have more questions than answers. We don't fully understand where Pluto's energy comes from, or how its atmospheric processes sustain themselves, or what all of this means for the possibility of life in extreme environments. But that's exactly what makes this moment so extraordinary. We're not just passive observers of a finished universe, we're active participants in uncovering its deepest secrets, one stunning discovery at a time. And those discoveries are reshaping not just our science, but our fundamental understanding of our place in the cosmos. As you sit there, 3 billion miles away from Pluto, think about what we've just discovered together. Even in our own solar system, our cosmic backyard, the place we thought we knew best, worlds are still surprising us in ways that challenge our most basic assumptions about how the universe works. A tiny, distant sphere no bigger than the continental United States has reminded us that the cosmos doesn't care about our expectations, our models, or our carefully constructed theories about what should and shouldn't be possible. Remember where we started? Something extraordinary happening right now, across that vast emptiness between worlds. That wasn't just a hook to grab your attention, it was the profound truth that defines our relationship with the universe. While we go about our daily lives, cosmic dramas are unfolding across distances so immense they humble the human imagination, yet close enough that our ingenuity can reach out and touch them. There's something deeply moving about humanity's drive to explore beyond our immediate world. We could have stayed content with what we could see with our own eyes, satisfied with the knowledge that served us for millennia. Instead, we built machines that can peer across billions of miles, decode the chemical signatures of alien atmospheres, and reveal secrets hidden in the darkness since before our species even existed. Each discovery makes the universe feel simultaneously larger and more intimate. Larger because every answer reveals 10 new questions, expanding the scope of what we don't yet understand. More intimate because we're learning that the fundamental processes of existence, chemistry, geology, evolution operate everywhere, connecting distant worlds to our own in ways we're only beginning to comprehend. Pluto isn't just a dwarf planet anymore. It's a reminder that the universe is far stranger, far more alive, and far more wonderful than we ever dared to imagine. And if a tiny, frozen world at the edge of our solar system can surprise us this profoundly, what other secrets are waiting out there in the darkness, ready to change everything we think we know? The journey of discovery is just beginning. If you're hungry for deep-dive cosmic revelations beyond surface-level space news, subscribe for more discoveries that change how you see the universe. Drop a comment. Which solar system object do you think will surprise us next? Europa? Titan? Maybe one of those mysterious objects beyond Neptune we've barely begun to explore? Share this with someone who loves cosmic mysteries. Help spread the wonder of ongoing space discoveries. More mind-bending revelations about our surprising solar system are coming soon. In an age of incredible discovery, the most important thing is staying curious.